So this video is going to go over compound inequalities. There's two different types of them, but this one's just going to talk about and. Next time we'll talk about or inequalities. So our goals are to be able to understand what a compound inequality is. We also want to be able to solve compound inequalities, and we want to graph solutions to compound inequalities. So let's talk about what a compound inequality is. This is basically just like a regular inequality. It's a statement of truth. The thing is that we're going to have two different inequalities. So like our answer is going to be constrained or bounded or restricted or whatever word you want to use. Restricted is a good one, by two different inequalities. That's why it's compound, because we have to like take one and add another one to it, and so it's like extra work, but it's not really that bad. And the answer has to fulfill the conditions of the two statements. So it has to be true for both things. You can't have it be true for one or the other, at least unless it specifically says that. So this is talking about and inequalities. And means that we have to fulfill both things. So our answer is going to be where the two inequalities intercept each other, or in other words, where they're going to be agreeing. Now, here's an example, and I want you to know that both of these mean the same thing. One of them looks a lot scarier than the other, but they're both exactly the same. So the nicer, friendlier version is like this, where we have two different inequalities. So we have 7 minus 4 is less than n, and n plus 4 is less than 9. So that means that n has to be greater than 7 minus 4, and n plus 4 has to be less than 9. The other way that we could write this is 7 is less than n plus 4, which is less than 9. Notice that the n is in the middle. It means that it has to be bigger than this stuff, because if we're reading backwards, it'd be n plus 4 is greater than 7, and it has to be less than this stuff because we're reading forwards. So let's talk about solving. Basically, you're going to treat them like a regular inequality when you solve it. The only thing is that you're going to be doing it with two of them. Remember, if we multiply or divide by a negative number, we're going to flip the sign. And if they're written with two signs, we're going to want to keep all three parts balanced. So remember before we'd have like two sides, so if we added 3 to one side, we had to add 3 to another. We'll throw something in there. Well, this time we're going to have to add 3 to all three sides so that everything is balanced. Here's my personal idea and my tip, and for me, granted, this is how my brain works. It's easier just to break them into two inequalities than to try and figure out how to do it on keeping the three parts balanced, especially when you have something with variables on both sides. It becomes really, really ugly, and it's easier just to break them into two inequalities. Let's attack this problem in two different ways. So we'll see this again in just another slide. We're going to start with the blue side, and what we're going to do is we're going to say 7 minus n is less than 4, or 7 minus 4 is less than n. N is our variable. Here's our variable. We can simplify these two. 7 minus 4 is 3. 3 is less than n. That's it. That's all we have to do with this one. But now we have to do this other one because we have that and. We have to do both of them. So n plus 4 is less than 9. N is our variable. N is on one side. We don't have to worry about it. The way to get it by itself is subtract 4. And then we end up with n is less than 5. This and comes down with us, so it's 3 is less than n, and n is less than 5. So our answer has to be between a 3 and a 5 for it to work. Let's attack it on a second way. So we have 7 is less than n plus 4, which is less than 9. Remember that we have to keep everything balanced. So n is our variable, it's right there. It's in one spot, so we're good with that. We're going to subtract 4 from all three sides. That cancels. 7 minus 4 is 3. The less than sign stays the same. N comes down. Our less than sign still stays the same. 9 minus 4 is going to be 5. So our final answer here is 3 is less than n, which is less than 5, which if we go backwards, you'll notice 3 is less than n, and n is less than 5. So it's the same thing, it's just written a little bit different way. Here's another example. 6 is less than or equal to m plus 6, which is less than or equal to 12. So m is our variable, m is in one spot, so we don't have it on like a different side. Let's start attacking the problem to get n by itself, m by itself. We'll subtract 6 from all three parts. 6 minus 6 is 0. The less than sign comes down. M, our less than sign, comes down again. 12 minus 6 is 6. So our answer here is that 0 is less than or equal to m, which is less than or equal to 6. Here's a quick check. I want you to solve these compound inequalities. They shouldn't be too bad. I'm looking through them real quick. No, they're not that bad at all. So solve these compound inequalities, and just remember what these are because we might want to graph them in a little bit. So go ahead and do that.